Scientists caution that if sunspots AR3697 and AR3664 strike Earth, they might cause powerful geomagnetic storms. The strongest solar storms in more than 20 years have already happened, and more are predicted to intensify. The greatest light show over Europe occurred in May 2024, when the night sky turned crimson, green, or blue. Massive solar storm activity caused the auroras, which are normally only seen in the most extreme polar locations. The Earth's magnetic field safety measures failed to stop a violent torrent of particles that reached the northern hemisphere and penetrated the surface. The storm persisted because the Earth's magnetic field safety measures malfunctioned. The biggest storm to hit the deep atmosphere in 201 years occurred, yet few local power providers reported issues or blackouts. Although Elon Musk's satellite survived the storm, things may have gone differently. The enormous sunspots that are causing the storms are resurfacing, and the worrying activity on the sun's surface may have led to a world emergency. Concerned scientists and amateur astronomers watched the events unfold, and in a matter of days, a number of smaller sunspots came together to form a massive sunspot that was 15 times larger than the Earth. On May 9, 2024, around 2 p.m. RST, NOAA's GO-16 satellite saw a solar flare that caused a massive stream of particles to break off from the sun and travel toward Earth. It was evident where the storm originated. Sunspot, Arkansas 3664. After a short while, the security systems issued a warning about a G4 geomagnetic storm. A G4 storm is categorized as moderate on the NOAA geomagnetic storm scale, and at worst, it can cause disruptions to satellite technology, power grids, navigational systems, near-pole air traffic, and other magnetic or electrical systems. The storm had almost reached Earth when, on May 10, 2024, Arkansas 3664 launched another flood of particles. The satellites recorded a powerful solar flare of class X58, which started at 3:20 a.m. On May 11, 2024, geologists recorded a massive strain on the magnetic field of the Earth for the first time. The charged particles from the sun interacted with the atmosphere so violently that the magnetic field displayed regional weaknesses and holes. The storm raged over the entire weekend, bringing us magnificent auroras once again, but also causing a number of problems in the power supplies. We don't yet know the full impact of disruptions to Earth's magnetic field, but it's anticipated that long-term harm might expose humans to higher radiation levels and possibly result in the passing of our atmosphere. Similar to what happened on Mars, that could have long-term effects. Class X87 solar flares, the greatest during the current solar cycle, were released by the largest sunspot on May 14, 2024, triggering the G5 storm about whom scientists had been receiving warnings for years. According to current solar cycle standards, this incident would be considered the biggest solar flare ever. Massive coronal ejections of this kind cause even more particle streams to be hurled towards Earth. The effects of this event on the Sun resulted in long-lasting geomagnetic storms on May 27, 2024. Shortwave radio transmitters and receivers failed, affecting emergency communication systems worldwide. This also affected military and maritime radio systems. Ordinary people all over the world were thrilled to see auroras in areas where they are not typically seen. Was demonstrated in May 2024 to alter the magnetic field all the way to the bottom of the ocean and to have measurable effects on deep-sea compass systems, upsetting undersea communications, for instance, reported on global power businesses. The recent spate of severe solar storms caused disruptions to several satellite operations and regional issues with the power line networks. AR3664 changes to AR3697. What is reasonable to anticipate? Did you realize that we can anticipate potentially dangerous emissions off the sun around the clock? Very few people on Earth are aware of this concern. Sunspots frequently occur and can pose difficulties for the United States, even at smaller sunspot sizes, which occasionally emerge fast and can emit enormous flames. These sunspots are visible to the unaided eye through protective lenses or through suitable telescopes, depending on their size. The Sun is made up of various layers, and the magnetic field is essentially produced inside the Sun. The magnetic layers are formed by the motion of electrically charged plasma inside the Sun. When these magnetic fields break through the surface of the Sun, they prevent hot plasma about rising from the interior, making the affected areas cooler and darker. The European Space Agency and NASA have been launching the Solar and Heliospheric Observatory, or SOHO, since December 1995. It continuously observes the Sun, registering variations in its surface and keeping an eye on its emissions. Like the James Webb Space Telescope, the spacecraft is situated 1.5 million kilometers from Earth. The Halala volcano on Maui is home to the largest solar observatory. In order to observe the Sun, solar observatories employ specialized filter technology and are shielded from the Sun's continual radiation. In April 2024, solar researchers in Hawaii and experts overseeing the SOHO facility note the formation of AR3664, a true giant between sunspots at the rising peak of the solar cycle. While the formation of even larger and more intriguing sunspots is normal, this time around things are different because, for the first time since 2003, Arkansas 3663 bombarded Earth with solar storms so intense that a permanent alarm was sounded after its first flare-up. The spot moved once around the blazing hot fireball together, the Sun's rotation axis, after a span of 27 days. It is difficult to imagine that there are areas of the Sun that are up to 15 times larger than our planet. These areas are cold and dark, and sunspots are caused by perfectly normal processes inside the Sun. Gases, plasma, and particles bubble in various layers that resemble onions. The magnetic field causes disturbances that humans can hardly imagine by thousands of tons of seething hot material. The object returned, then pointed directly towards Earth again, and the researchers were warned once more that AR3663 had changed as it orbited the Sun flare, or CME, which is more intense. As magnetic field lines twist between the layers, it rises, sinks, bubbles, or cools suddenly. This produces a sunspot that is noticeably darker than all surrounding areas, and cooler as a result of the cooling and an effect known to scientists as magnetic reconnection. The phenomenon known as solar flares, also called coronal mass ejections, or CMEs, releases massive amounts of energy suddenly. The difference between solar flares and CMEs, in short, is the formation and amount of material released. Solar flares are caused by a rapid emission of energy light and high-charged particles generated by twisted magnetic fields. Alternatively, CMEs are massive bubbles of plasma, as well as magnetic fields that are driven into space by the Sun's corona. When these bubbles strike the Earth, they can trigger geomagnetic storms, which are similar to flares in that they can interfere with electrical systems, satellites, and navigation systems, as well as cause intense auroras. While CMEs carry more mass, they frequently take days to reach us, endangering change. Flares are typically composed of less dense particle streams that strike us faster, in a matter of minutes or hours. AR3697 replaces AR3664. Even though sunspot AR3664 may have faded away, it has changed and isn't finished yet. When AR3664 returned to the Sun after wandering for 27 days, it underwent an enormous shift due to the streaking of numerous magnetic field lines. On its return, the spot became recognized as AR3697, which is quite normal. The spot, which has grown again, could continue to cause severe damage on Earth in the future. It is customary to call things after a circuit of the Sun, which aids in the ongoing observation and analysis of these phenomena by researchers. On May 27, 2024, an X-28 flare struck us, and a week later, Arkansas 3697 launched an X-14 flare in our direction. AR3697 thereafter resumed its exceptionally intensive activity. This solar cycle, known as Solar Cycle 25, began in December 2019 and is expected to last for a full 11 years. We will not know what this solar cycle will bring to us until we have passed the peak, because we are just at the beginning of the most intense solar activity. The expected peak will be in 2025. If these numerous powerful gets were really just the harbingers, that we must prepare one another for extreme stress. These flares have once again caused geomagnetic problems and shortwave radius system failures around the globe. Thank you for watching this video.